Good morning students. Today our topic is analysis of variance. It is called Anova also and it was developed by Ronald D. Fisher, a renowned British statistician, and was reported by him in 1923. The name F-test was given to by Fisher's honor, in Fisher's honor. Since that time, it has found wide application in many areas of experimentation. Its early application was in the field of agriculture. This device has made tremendous contributions to designing of experiment and their statistical analysis. Now, why analysis of variance is required and when it is used? We discussed earlier about z-test and t-tests for testing the significance of the difference between the means of two samples or groups. In practice, however, we often come across situations where we have several samples of the same general character drawn from a given population and wish to know whether there are any significant differences between the means of these samples. In such situations, instead of determining a single difference between two means, several differences between several means are determined. However, after we decide to do so much labor, there is no guarantee that we would get the desired results. There is a possibility that none of the differences between pairs could prove to be significant, and in such a case, the cumbersome exercise of computing a number of z and t values for testing the significance between several pairs of means will be complete waste. Thus, we may conclude that the usual procedure of testing the significance between two means by t and z test definitely needs a substitute in the form of a single composite test for simultaneously testing the differences between the means of several samples of groups. The solution to this problem lies in a statistical technique known by the name analysis of variance, in which all the data are treated together and a general null hypothesis of no difference among the means of the various samples or groups is tested. A composite procedure for testing simultaneously the difference between several sample means is known as the analysis of variance. It helps us to know whether any of the differences between the means of the given samples are significant. If the answer is yes, we examine pairs to see just where the significant differences lie. If the answer is no, we do not proceed further. In such a test, as the name implies, we usually deal with the analysis of the variances. Variance is simply the arithmetic average of the square deviations from their means. In other words, it is square of the standard deviation. Variance has a quality which makes it especially useful. It has an additive property which the standard deviation with its square root doesn't possess. Variance on this account can be added up and broken down into components. Hence, the term analysis of variance deals with the task for analyzing of breaking up the total variance of a large sample or a population consisting of a number of equal groups or subsamples into two components. First component is within group variance and second component is between group variance. Within group variance, this is the average variance of the members of each group around their respective group means or the mean value of the scores in a sample. Second is between group variance. This represents the variance of group means around the total or grand mean of all the groups or the best estimate of the population mean. For example, there are 40 boys in all belonging to 4 different localities, and if we add the IQ scores of these 40 boys and divide the sum by 40, we get the value of the grand or general mean. The best estimate of the population mean it is, there are 4 groups or of 10 boys each. The mean of the IQ scores of 10 boys in each group is called the group mean, and in this way there will be 4 group means which will vary considerably from each other. Now the question arises as to how far does an IQ score of a particular boy belonging to a particular sample or group deviate from the grand mean for 40 boys. We may observe that the deviation have two parts, either deviation of the score from the mean of that particular group and the deviation of the mean of the group from the grand mean. Now we will do it with the help of example on the board. Suppose that we have 4 groups and in each group we have 10 students. It is group A, group B, group C and group D. There are 10 students in group A. Suppose that they are x1 and up to x10. In group B, it is B1 up to B10. In group C, there are 10 students, C1 up to C10, and in group D, number of students is D1 up to D10. And if we calculate the the mean of each group, then suppose that the mean of group A is x bar, mean of group B is B bar, as mean is represented by x bar, so we have taken these symbols. Group C, mean of group C is C bar, and in group D, the mean of the group is D bar. These are the separate means of each group. But if we calculate the total mean of the whole group, then we will have to add the number of students in group A plus number of students in group B plus number of students in group C and number of students in group D. That will be called the population mean, or we can say the grand mean. And suppose that it is represented by S bar. Grand mean is represented by S bar. Now the analysis of variance is broken in two parts. First part is the deviation of the scores from their mean, that is called within group variation. And this variation is variation of these scores x1, x2, x3 and up to x10 from their mean x bar. This is first kind of variation, that is within group variation. It means the variation of the scores from their mean. Similarly, in group B there are 10 students, B1 up to B10, and their deviation from the mean B bar. And similarly, the deviation of the number of students in group C from their mean C bar, and in D, variation of the score from D bar. It is called within group variation. But the difference between X bar and S bar, B bar and S bar, C bar and S bar, D bar and S bar, it is called the variation of the means from the grand mean. In this manner, we have broken the total variance. Total variance is the difference of the scores of each group from the grand mean S bar is broken into two parts: deviation of the scores from their mean and deviation of the mean from grand mean. So this was the analysis of variance. Now, how we calculate the analysis of variance? The deviation of individual score belonging to a sample or a graph of population from the grand mean can be divided into two parts, as we have discussed on the board also. Deviation of the individual score from his group mean and deviation of the group mean from the grand mean. Consequently, the total variance of the scores of all individuals included in the study may be partitioned into within group variance and between group variance. The formula used for computation of variance is summation x squared by n. Sum of the square deviation from the mean value divided by total frequencies. Hence, by taking n as the common denominator, the total sum of square deviation of scores around the mean, general mean for all groups combined can be equal to the sum of two partition between groups and within groups sum of squares mathematically. And in its formula is total sum of squares is equal to between group sum of squares within group sum of squares, and it is written as total sum of squares ST square is equal to SW square within group sum of squares plus between group sum of squares, because we have broken analysis of variance in two parts: within group sum of squares and between group sum of squares. Now, what are the uses of Anova, where we can use it? The Anova technique is useful in testing differences between two or more treatment means. Its special merit lies in testing differences between all the means at the same time. The Anova is a powerful aid to the researcher, as it helps him in designing an experiment efficiently and enables him to take account of interacting variables. It also aids in testing hypotheses. Thus, Anova hypothesis testing procedure that is used to evaluate mean differences between two or more treatments. As with all inferential procedures, Anova uses simple data as the basis of drawing general conclusion about population. It may appear that F and T tests are simply two different ways of doing exactly the same job, testing the main differences. In some respects, This is true, both tests use simple data to test hypotheses about population means. However, F-test has a tremendous advantages over T-test. Especially, T-test is limited to two situations where there are only two treatments to compare. The major advantage of Anova is that it can be used to compare two or more treatments. Thus, Anova provides researchers with much greater flexibility in designing experiments and interpreting results. Therefore, Anova is much more needed than the T-test. Like the T-test, Anova can be used with either an independent measure or repeated measures design. As mentioned earlier, one should recall that an independent measures design means that there is a separate sample of n subjects for each of the treatments being compared. The design is otherwise known as randomized group design or between group design. In a repeated measures design, on the contrary, the same sample of n numbers is tested in all the different treatment conditions. The design is otherwise known as within group design. In addition, Anova can be used to evaluate the result of a research study that involves more than one independent variable or factors. For example, an investigator might want to compare the effectiveness of two different teaching methods. These are called independent variables. For three different class sizes, these are also independent variable. The structure of this research study is 2 by 3 factorial design, which involves comparing independent samples means from 6 different treatment combinations. A separate randomized group is used for each treatment condition. The dependent variable for this study would be each subject's score on the standardized achievements. As we can see, Anova provides researchers with an extremely flexible data analysis technique. It can be used to evaluate the significance of main differences in a wide variety of research situations and each one of the most commonly used hypothesis testing procedures. In a study where the researcher manipulates a variable to create different treatment conditions, the variable is called independent variable or treatment variable. On the contrary, when a researcher uses a non-manipulated variable to differentiate group of subjects, the variable called a quasi-independent variable. For example, class size as method of teaching are independent variables, whereas age, sex are the quasi-independent variables. In this context, we can say that Anova is an independent variable. In context of Anova, an independent variable or quasi-independent variables is called a factor. And this was all about the analysis of variance. Thank you very much.